So today we're going to be taking notes on section 4.1, Congruent Figures, and this is a start of a new unit, and we're going to use all the information we learned from our proofwriting unit, proofwriting week actually, and help us create some triangle proofs within this unit. So we are going to talk about what congruent means. Congruent figures can be congruent as long as they have the same size and same shape. Same size and same shape. So what geometric objects can be congruent? Okay, so let's think about the things that we have stated were congruent to each other already. We've had a segment congruent to a segment. We've had an angle congruent to an angle. And up until this point, these are the only two congruent statements that we've had. Can we have an angle congruent to a segment? No, we cannot. An angle and a segment are two different shapes. They're two different geometric objects. So we cannot prove them congruent. The things that we will say are congruent this unit, our goal is to create triangle proofs where we have a triangle congruent to a triangle. But could a triangle be congruent to, let's say, a square? Are those the same shape? They are not. So we need to have the same shape and the same size. So we're going to start off with an example. Let's draw these two triangles and let's make them big enough because we're going to mark them up somehow. So these triangles are congruent. So that means that they have the same size and the same shape. And that also means that the congruent figures have corresponding parts. Congruent figures have corresponding parts. So if I were to take a scissor and cut this triangle off and place it directly on top of this other triangle, what vertex points would match up? Okay, the vertex points that match up. A matches onto D, B matches onto E, and C matches on to F. Okay, and so the parts that are congruent in these triangles, a triangle is made up of segments and angles. So not only do the vertex points match up, but the angles match up and the segments match up. Okay, so angle A would land directly on top of angle D. So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Okay, and notice how we have to use the single tick mark, a double tick mark, and a triple tick mark for those angles. That's something that we haven't really been practicing too much recently, so it's something to remind ourselves of. Now, which segments are congruent? Let's see, A to C would land directly on top of D to F. So AC is congruent to segment DF. CB would land directly on top of FE. And AB would be congruent to DE. Okay. So notice here that we have 1, 2, 3, 4, 5, 6 pieces of information that we can take away from this problem by just knowing that these triangles are congruent. So these are called the corresponding parts. They are the corresponding parts of these two congruent triangles. So something to keep in mind, making sure that we're labeling the triangles. marking the congruence properly, and recognizing which angles land on top of the other angles and which sides land on top of the other sides. So congruent figures have a matching up of vertices, sides, and angles, as we just discussed. So if we think about cutting out one of the triangles with a scissor and then placing it on top of the other, they should match up directly, and we should see that all the angles, all the sides, land directly on top of each other for those two triangles. So now we're going to think about this question. What information would we need to know to prove that these triangles are congruent? So a lot of geometry is assumptions. So initially, for that previous problem, I told you that these triangles were congruent. But now I'm saying we don't know if these triangles are congruent. So what information would we need to prove that they are congruent? We would need to prove that 6 pieces of information. We would need to show that all corresponding angles are congruent, right? So that was 3 pieces of information, and all corresponding sides are congruent. That was another 3 bits of information. So if we can prove every bit of these 2 triangles are congruent, 3 tick marks, then we can say that because all of their corresponding parts match up, all the vertex points match up and are congruent, then we can show that the triangles themselves are congruent. But right now we need 6 pieces of information to do that. We need to prove that all the angles are congruent and all the corresponding sides are congruent. So here is the definition of congruent triangles. So 2 triangles are congruent if their vertices can be matched up so that all the corresponding parts are congruent. So when we say parts, we mean angles, sides, right? Those are the parts of a triangle. A triangle is created triangle has angles and sides. Those are the parts of that triangle. So now, given this diagram, we have 4 triangles here, and I want us to determine which 2 triangles are congruent. And now we have to pay attention. We have to pay close attention to the tick marks on the diagrams. So I want everyone to look at this for a moment on their own, and I want you to see which 2 triangles have the same or similar tick marks. So I'm going to label them 1, 2, 3, and 4 for now, so we can see which 2 are going to be congruent. So let's start here. In triangle number 1, notice how we have a single tick mark. And triangle number 2, we don't have a single tick mark. Okay, so those 2 are not congruent. But for triangle 3, we do have a single tick mark, so they could be congruent. But notice how the angles in triangle 3 don't match up with the same tick marks that we have in triangle 1. So that one wouldn't be congruent. But now if we looked at triangle 4, notice how we have a single tick mark here. And then we have 2 tick marks in number 1. We also have 2 tick marks on the sides in number 4. And then we have 3 tick marks on number 1 and 3 on number 4. And then we have a single, double, and triple tick mark angles. So we see that these 2 triangles, triangle 1 and triangle 4, are congruent. So now we have to name these triangles, okay? We want to name which triangles are congruent. And it's very important for us to name the triangles in a certain way. Okay, so notice how number 1 and number 4, right? Number 4 is kind of like flipped, spun. So if we like spun it on the table, it doesn't look exactly the same. So we have to think about which vertex points match up. So I always like looking at the single tick mark angle. So I'm going to circle the single tick mark angle number 1. I'm going to circle the single tick mark angle in number 4. So that means angle S and angle E match up. Then I'm going to look at the double tick mark angle. Double tick mark angle. T and F match up. So how we state that these triangles are congruent, if I said ST, triangle STR, I could say that's congruent to triangle EFD. Okay, so that means S and E correspond, T and F correspond, R and D correspond. So we have to name these triangles congruent in this particular order. So when naming congruent figures, order matters. It matters. We need to name the triangles in a very specific order. Okay, so what conclusions can you make if you know that triangle ABC is congruent to triangle XYZ? So just by looking at it, we have ABC and XYZ. And now that we know that order matters, what would angle A correspond to, since it's listed first? It would correspond to X. What would angle B correspond to, because it's listed second? It would correspond to angle Y. And C would correspond to angle Z. So to identify the congruent angles, it's easier to do without a diagram. But drawing diagrams are going to be super helpful. So I just draw a regular old plane A, B, C, X, Y, Z. Okay, so I know that my A and X match up, my B and Y match up, and then my C and Z match up. Okay, sometimes it helps also to put some shapes around those vertex points so you can see which ones match up. So now I'm going to mark which sides are congruent. Single tick mark, double tick mark, triple tick mark. So now we can name them. We say, segment AB is congruent to segment XY. Segment BC is congruent to segment YZ. And segment CA is congruent to segment ZX. So again, here are 1, 2, 3, 4, 5, 6 bits of information that we can gather from just knowing that these two triangles are congruent. And we know that they're congruent because it states it in the problem. Okay. So if we know that triangles are congruent, then we can conclude that their corresponding parts of congruent triangles are congruent. So going back to this last slide, if we know that two triangles are congruent, then we can conclude 6 bits of information about those two triangles, right? We can gather that all the corresponding angles are congruent. We can gather that all the corresponding sides are congruent. So this is a definition of congruent triangles. It states that the corresponding parts of congruent triangles are congruent. So let's repeat this a few times together. And you're going to say it out loud. You're going to talk to yourself while you're watching this video. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. And that's a lot of, it's a lot of words to remember. So we can abbreviate it to CPCTC. Corresponding parts of congruent triangles are congruent. And that stands for CPCTC. CPCTC. All right, so see how many times you could say that fast. This is something that we're going to keep coming back to. Make sure you write it down. Make sure you understand what this is saying. So there's a worksheet that's posted to Schoology, and feel free to print, and you're going to submit your notes from the video and work on these problems, and we're going to check these answers in class tomorrow. If you don't have the worksheet in front of you, I will go through these slides slowly, and you can pause, do the problem, and keep going. So here's number 1. Here's number 2. Here's number 3. And number 4. And lastly, number 5.